Good morning, geometry. Today we are going to do chapter 5.3. So we're going to continue talking about lines or segments that intersect triangles in different ways. The first one that we're going to talk about is a median. So a median of a triangle has an endpoint at a vertex, and the other midpoint is at the midpoint of the side. The other endpoint is at the midpoint of the side opposite the vertex. So this should be endpoint. Sorry about that. So BD is a median because it intersects a vertex and the opposite side is in the middle, or it's the midpoint of that opposite side. Now this is different from a perpendicular bisector, because a perpendicular bisector, even though it cuts this in half, it does not have to go through the vertex. It just has to create a 90-degree angle. So that brings us to an altitude. So an altitude is a perpendicular segment from a vertex of a triangle to the line containing the side opposite the vertex. So we don't have to cut, just like a perpendicular bisector has to be perpendicular and cut the line in half. An altitude just has to start at a vertex and be perpendicular. So you notice that in this case, the perpendicular or the altitude actually intersects segment CD outside of the triangle, which is okay. Okay, so we're learning lots of different vocabulary words in this chapter, and you need to understand the difference between all of them because we will be using them again. So let's take a look at some problems and some more information on medians and altitudes. The medians of a triangle are concurrent. Remember, that's a point where 3 or more lines intersect at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. The point of concurrency is called the centroid. Okay, so the centroid, what this means is that this distance from A to G, in other words, from a vertex to the centroid, is 2/3 of the entire length of AD. And from G to D is 1/3 of that length. So anytime I'm solving problems with this, I like to draw a little fraction strip. Okay, so it's 3 separate sections because it's broken up into 3 sections. And from A to G is 2/3 of it. And from G to D is the last third. I just noticed that students tend to be able to picture that better and tend to be able to solve the problems better when it's broken up that way. So let's go on ahead and take a look at some median or centroid problems. So this one says find AD. So we want to find this distance all the way to there. Okay. So what we know is that AE equals 2/3 of the total distance from A to D. So we know that 21 equals 2/3 AD. So how do we get AD by itself? We multiply by 3/2 because we have to divide by 2/3, but we never divide by a fraction, we multiply instead. Okay. So that means that this right here is going to be multiplied by 3/2. So 21 times 3, and then divide that by 2, and it looks like it's 31.5 equals the distance from A to D. Now let's do it the way that I like to do it and show you why I prefer to do it that way. So all right, so here is our 3 sections, and so from A to E is 2/3, and then we have to D. So we know AE is 21. So if we break 21 up into these 2/3 sections, we get 10.5 for each. So there's 10.5, 10.5, which means our last third has to be 10.5 because this is a fraction strip. Every section has to have the same length. So now what's 10.5 times 3? That's 31.5. Okay, so either way works. You can do it either way. Like I said, I just noticed a lot of times that students tend to do better with the fractions. Okay, so let's take a look at another problem here. So this one says find AD, and it gives us the distance from D to E. So I'm just going to draw my fraction strip. It's always in thirds. From the vertex to the centroid is 2/3, and the rest of that length is 1/3. So I know from E to D is 12, which means each of these is 12. So now 12 times 3 is 36. And now if you want to do it the other way, that's perfectly fine. So we know that from E to D is 1/3 the distance of AD. So now let's plug in what we know. We know that 12 equals 1/3 AD. So now we're going to multiply both sides by 3, and we get 36 equals AD. Okay, so either way, we're going to wind up with the same thing. Just some students really like to see it in picture form, and some like the formula. The one thing that you have to remember about the formula, and the same with the fraction strips, is you have to remember whether it's the 2/3 part, so from the vertex to the centroid, or whether it's the 1/3 part, which is from the centroid to the segment. All right, so this last one here says find the centroid. Okay, so if you're given a shape and you need to find the centroid, the very first thing that we're going to have to do is we are going to have to find the midpoints of at least 2 sides. Okay, so this is, it looks like 30, we'll say 34 centimeters. So that's going to be 17. So that's going to be right about here. And our median goes from the midpoint to a vertex. Now I'm going to find the midpoint of another side. It doesn't matter which one. Okay, so this is, it looks like 42. So that's going to be 21. And now I need to draw a line from the midpoint to the opposite vertex. And they intersect right there. If I do the third side, it should intersect in the exact same spot. So I'm just going to do that to show you. So that looks like 38. So that's going to be 19. If I cut it in half, which would be right about there. And if I draw this, it's going to cut through the same spot, the centroid. Okay. All right, so the next one is called the orthocenter. The orthocenter is the point of concurrency of 3 altitudes of a triangle. So remember that if we have a triangle and we have 3 altitudes, that means that it is going at a 90-degree angle from the vertex. Okay, so there, and I'm just kind of sketching this out. Okay, it would have to be a 90-degree angle. Okay, so it doesn't necessarily cut anything in half. We just know that it has to be a 90-degree angle. Okay, so our orthocenter would be right there. So how do we find the orthocenter of a triangle? Well, we know that it's a 90-degree angle. So if I have this segment here and I'm looking for a segment that's a 90-degree angle, I know what my slope from the opposite vertex would be. Because remember that a perpendicular slope is the negative reciprocal. Reciprocal. Okay. So the negative reciprocal. So what that means is that the fraction is flipped and the sign on the entire fraction is changed. Okay. So it doesn't matter if there's a negative sign in the bottom or the top, that entire fraction sign has changed. So let's go on ahead and take a look at this. So the first thing I need to do, looking at ML, segment ML, is I need to find its slope. Okay, so slope, if you'll recall, is y2 minus y1 over x2 minus x1. So I'm just going to plug in those points. So I will call M my y2 and my x2, y2, my point 2. So that's going to be 12 minus 5. And since I started with my point M up here, I need to start with my point M for my x's. So that's 3 minus 10. So 12 minus 5 is 7 over negative 7. Okay, so that's going to be negative 1 over 1. I just like to keep it as a fraction so that when I flip it, I remember what it becomes. So now I have to flip this fraction. So it's going to become 1 over 1. And the sign is going to change. So it's going to be positive 1 over 1. So from my opposite vertex, I'm going to go up 1 over 1, up 1 over 1. And I'm going to go until I at least intersect this segment. So now I can connect my points, okay, and know that I have a right angle that starts at segment ML and goes to the opposite vertex. Okay, but now I need to find the orthocenter, so I need at least one more spot. So I could use either segment KL or segment KM. I'm just going to go ahead and use segment KL here. Okay, so let's see, we'll do that in, let's go with pink. Okay, so there's segment KL. So I'm just going to do my slope again. So that's going to be 5 minus 0 over 10 minus 0 is 5 over 10, which we could reduce to 1/2. So now I need to flip that and change the sign on that. So I'm going to get negative 2 over 1. Okay. So from this vertex opposite, I need to go down 2 over 1, down 2 over 1, until I have at least intersected that opposite side. So that would be right there. So I'm looking at my orthocenter being at the location, it looks like 6, 6. And I'm just going to double check it by doing my third and final segment here. Hey, you don't have to, but I'm going to go on ahead and check it, because if you check it and they all intersect at the same spot, then you know you've done it right. If you only do 2 lines, then it could be right, but you could have made a mistake. Okay, so we're going to have M equals, so that's 12, take away 0, and that's going to be 3, take away 0. So that's going to be 12 over 3, which reduces to 4 over 1. Okay, so now I'm going to flip that and change the sign. So it's going to be negative 1 over 4. So from my opposite, so this is the segment, so this would be my opposite vertex, I'm going to go negative 1/4. And remember that as a slope, this could also be 1 over negative 4. Okay, the whole fraction is negative, which means our slope is negative. Okay. So in this case, I'm going to go up 1 and back 1, 2, 3, 4. Up 1, back 1, 2, 3, 4. Okay, and then I can connect those points. And as you can see, I actually hit the center or the orthocenter here when I did it. So I know now 100% that that's in the right spot. Okay, so my orthocenter is at 6, 6. I'm going ahead and do your homework on this, ask questions if you have any, and have a great day.